So what I'm going to do now is I'm just going to quickly run through some basics. Matrix, I know that these are things that you've been learning about for 2 years already, but this trig, the cast diagram, general solutions, all those things are new for the grade 11s. So I just want to whip through some basics, some rules, whatever, and then I think that'll sort of ease us into things a little bit faster or a little bit easier than when we start going and working through the questions that I have given you. Okay, so I'm scooching over to the side, and this is what we need to know for grade 11 and grade 12. Okay, and some of this seems a little bit basic and straightforward, but that is what is required of us. Okay, so when we see sine theta, we know that it means y over r. Cos theta is x over r. Tan theta is y over x. All right, so when they want us to substitute in place of tan theta, they want us to write y over x. If they want us to substitute in place of cos theta, they want us to write x over r. These are important for our Pythagoras type questions, okay, where we're going to be substituting in values. All right, we'll talk about that a little bit more when we go and have a look at our first questions. This diagram on the right-hand side over here, where I'm putting a blue arrow, what's that called? What's this diagram called? When we look at it. That's it. This is our cast diagram, 100%. Okay, so we say quadrant number 4 is C, quadrant number 1 is A, quadrant number 2 is S, and quadrant number 3 is T. This is our cast diagram. And as all of you know by now, I'm just reminding you, we've decided that's 0 degrees, that's 90 degrees, this is 180 degrees, this is 270 degrees, and when we get back here, we've ended up back at 360 degrees. Okay, so we can describe quadrant 1 either as theta, because theta is an acute angle, so we can use theta for quadrant 1, or we can use 90 minus theta, but we'll come back to that. For quadrant number 2, our reduction formulae are either 90 plus theta or 180 minus theta. For quadrant 3, 180 plus theta, and for quadrant 4, it's 360 minus theta. Now, the reason that we have these grade 11s and I suppose grade 12s as well is because we are talking about a terminal arm that's anchored in the origin and that swings around the Cartesian plane in an anti-clockwise direction. All right, so when we go in this direction, okay, angles are positive. So angles are positive. When we go in the opposite direction, so that way around, that's where we get negative angles from. Angles are negative. Okay, so if I come to rest over here and I say that that is theta, then that is negative theta because I've gone in the opposite direction. Okay, so that's why angles could be positive or negative. We are talking about directions. Okay, so I'm just going to get rid of all of those. Okay, so what you need to make sure that you have learned off by heart, okay, are all your reduction formulae and your co-functions as well. All right, grade 11s, do you, and grade 12s, do you know your reduction formulae? Yes.
Nice, guys.
Okay.
Wow.
All right, so I'm just gauging to see whether I need to revise all of this or we know our reduction. You've learned your reduction formulae. So if somebody comes along and says to you cos 180 plus theta, you know what to write. Yes,
I think I
yes.
only realized the one known so far.
Okay, all right. Okay, so you have to learn your reduction formula. I'm just going to remind you about the 90 minus and the 90 plus, because those ones are a little bit different. Okay, so when we've got sine 90 minus theta or cos 90 minus theta, remember this reduces to cos theta. Okay, these are our co-functions. Cos 90 minus theta becomes sine theta. And then again, we've got sine 90 plus theta. That's the second quadrant, because we've gone to 90 and then we've gone theta degrees forward into quadrant 2. So this is cos theta. And then we've also got cos 90 plus theta, second quadrant, where cos theta is negative. So this becomes negative sine theta. So very important, grade 11s and grade 12s, when you are applying your grade 11 reduction formulae, you have to write what you get as a result of reducing. Okay, whether you are in grade 11 or in grade 12, you are going to get a mark for that. So you have to write what you get before you then go on and do whatever else is necessary in a particular question. Talking about negative angles, just very quickly. All right, so negative angles like sine minus theta, here are negative angles over there. We treat this like we are in the fourth quadrant. So in other words, if I've done that, okay, but I haven't gone past 270. So I'm sitting here in the fourth quadrant. Okay, so y is negative in the fourth quadrant. That's why we get negative sine theta. Cos minus theta gives us positive sine theta, because x and r are positive. Well, x is positive in quadrant 4, r is always positive. And tan minus theta reduces to minus tan theta, because y is negative in the fourth quadrant. Okay, so those are some more reduction formulae, essentially, but with our negative angles. Okay, is everything okay so far? Any questions? Am I telling you everything you already know?
Take screenshots if you can, because writing might take longer.
Yeah. Is everybody happy? Haven't left anyone behind anywhere?
Nice, guys. Okay.
Okay. All right, that's fine. Then here, what I've done is it's up to you. I'm not sure how Mr. S, I think is what the grade 11s call their teacher here at Watobe. I'm not sure how he has taught special angles to you, or how your teachers have taught it to you at school. Personally, I think that the triangles are the quickest, easiest way to do it. There's also a fan. You can also make a table. I think that the triangles are the quickest, easiest way. So that's why I've put these here, just to remind you. We're going to be referring to these in our lesson as well. So don't forget about our special angles: 0 degrees, 30 degrees, 45 degrees, and 60 degrees. We'll come back to those. So if you want to screenshot those. And then as far as our grade 11s are concerned, you learned about two identities in grade 11. You learned the tan identity, okay, which is sine theta over cos theta, and you've learned about the square identity, sine squared theta plus cos squared theta is equal to 1. All right, so just going back to the tan identity, I just want to point a couple of things that do tend to come up that maybe when we're teaching, we don't actually talk about, okay? The first thing is that if you have tan squared theta, then you would write that as sine squared theta over cos squared theta. Matrix, okay, because the grade 11s are not really going to work with this. If you have got tan 2 theta, all right, you would write this as sine 2 theta over cos 2 theta. Okay, but this is grade 12s more than grade 11s. Okay, the other thing that they sometimes sneak in as well is they give you something like this, the tan of 90 minus theta. Okay, so you would rewrite that as sine 90 minus theta over cos. Whoopsie, I'm combining my, what on earth is that? Sorry, guys. Hold on. Let me just try and write that again. That didn't come out the way I intended. Okay, so this is 90 minus theta like that. Okay, so just remember when we talk about your tan identity, it applies to squares, to double angles, the tan of any angle. Okay, all right, so those are just some of the things that you may see. You might even see tan 90 plus theta, in which case you would write it as sine 90 plus theta over cos 90 plus theta. Okay, and then go from there. Maybe I should just sneak that one in quickly over here. And that would be sine 90 plus theta over cos. All right, and then obviously you would then need to simplify or apply further formulae or whatever the case is in situations like this. Okay, all right, so that's just your first line after writing tan theta as sine theta over cos theta. As far as your square identity is concerned, so this is the tan identity over here. It's the tan identity. The square identity is the second one. So sine squared theta plus cos squared theta equals 1. Okay, matrix, this is also, I mean, both of these are important for us in matric. Often in matric, if we get stuck, it's because we're not thinking about our grade 11 identities. So these are really important. And remember, we can also manipulate our square identity in the following way. So in other words, we can write cos squared theta as 1 minus sine squared theta. Okay, so don't forget about being able to do that. And similarly, we can rewrite sine squared theta as 1 minus cos squared theta. Okay, we could even take that one step further if we needed to, not always. Right, and this is the hard part, is it when do we know when we're supposed to do it or when we're not supposed to do it? But we can actually factorize the right-hand side of both of these because it's difference of two squares. So if you needed to, you could rewrite 1 minus sine squared theta as 1 plus sine theta times 1 minus sine theta. Okay, sometimes useful in identities when we need to cancel down. And same story on this side. So this could be written as 1 minus cos theta times 1 plus cos theta. All right, if we needed to do that. Okay, everybody okay so far still? Are we all sure? Thumbs up, thumbs down. Any questions? Have I left anyone behind anywhere? Are we all good? Okay.
Sorry, Uratile put
Okay.
thumbs
Yeah, I
down.
see
What will I
Oratile
do
put a
there?
thumbs down. Oratile, do you want to ask a question? Is there something that you're lost on? Yes, Oratile, please go ahead.
Uratile, you are still muted. You need to unmute yourself on your side. There we go.
Afternoon, madam.
Afternoon, Oratile. How can I help you? What's wrong?
Madam, on the sine squared theta is equals to 1 minus sine squared theta. So I see that you multiplied the brackets. Is it that they're gonna like foil? They're gonna multiply each other out until we get.
Yes.
Okay,
Yes.
okay.
Yes,
That's what
yes,
I want.
exactly. Yeah, no, absolutely. So sometimes you may
It
need
is
to do that.
foil.
Sometimes, yes, it's just foil. It's just
Okay.
foil.
I was
Okay, so
just
when you,
confused on that part.
yeah, no, no
Thank you,
problem
madam.
at all. No problem at all. Absolutely. Okay, so sometimes we need to factorize, sometimes we don't. Okay, so now grade 11s, don't stress. This is the matrix. Matrix, you know this. These are your compound angle formulae, which you are all very well aware of, and your double angle formulae. Okay, so in addition to knowing all of this stuff from grade 11, the matrix also need to learn about compound angles and double angles as well. Okay, hopefully matrix, you've got your formula sheets with you and you've got all of this in front of you as well. If not, we can always come back and refer to these, but we've worked with these a lot. We should actually pretty much know them off by heart now as well. And we're going to see where we're going to apply them in the questions that we're doing. Okay, so let's jump ahead and let's go back to the questions that we had done. Okay, so the grade 11s and the grade 12s, I gave you a similar question to do, all right, on the theorem of Pythagoras, okay, because I wanted you to see what gets asked. Well, the grade 12s will know what gets asked in grade 11, but so that the grade 11s can also see what gets asked in grade 12. Okay, so as far as the grade 11s were concerned, right, what I'm going to do is I'm going to give you, because has everybody managed to work through this question at least? Yes, 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 yes. If you're in grade 11 or grade 12, you've worked through this. Okay, all right. So grade 11s, first of all, right, and grade 12s, you can obviously listen to all of this because this applies to you as well. We are given OT. T is a point in the second quadrant. OT is 17 units long. They've told us that over there. And they've given us point P, which has coordinates -2 and A, and the x coordinate at T is missing. So the first thing that they want us to do is calculate the value of x. All right, so not all. Okay, that is not a problem in the slightest. Did you manage to calculate that x was equal to -8? Did you get that as a solution? Yes. Okay. So we remembered no. Okay. All right. So the person who said no, in order to calculate x, you're subbing into Pythagoras. So it was x squared plus 15 squared equals 17 squared. Okay. So you get a mark for subbing in, and then you would have to end up with this. And then you've got to be careful, okay, because you are working in the second quadrant. All right, so that's how you would have got x is equal to -8, and that's where the second mark would have been. All right, now, in the beginning, when I had said tan theta is y over r. That's what they want from you here. They want you to write y over r for this diagram. So it helps if you have something on the side where you say, okay, I worked out what x is. It's -8. I know what y is. It's 15. I know what r is. It's 17. So as far as tan theta is concerned, it's only 1 mark because they just want you to write y over x. Okay, so it was 15 over -8. That's what you should have got for that second one. That's it. Well done, Mesh. Perfect. Okay, this over here is out of 2 marks. Cos 180 minus theta. Okay, because you have to do a reduction formulae, or you apply a reduction first. Okay, so what you should have done here is first written this as negative cos theta. That would have given you 1 mark. And then remember, cos theta is x over r. Okay, so that would have been -8 over 17, which would have given you 8 over 17. A mark here and a mark here. Okay. All right, the next one, 514, sine squared theta. So they're asking you to write y over r and square it. All right, so you would have put 15 over 17 and squared it. This would have given you 225 over 289. And then the last one is something that you possibly may have struggled with. How did we do with the first few questions? Grade 11s, were you okay? Any questions, grade 11s with the first little bits? You sure? All right. Okay, so maybe the more difficult work is the next thing that's going to come up. All right, so this last question here, 515, the value of A. All right, so we could actually use, because point P and point T lie on the same straight line, we can actually use ratio. All right, so x is to 15 is the same as minus 2 is to a. You can actually use a ratio. So in other words, you know that x was equal to negative 8. So negative 8 is to 15 is the same as minus 2 is to a. All right, so, and then you can just cross multiply. They're in the same proportion. All right, so you would have ended up with negative 8a equals negative 30. And then when you divide both sides by negative 8, you would have ended up with a being equal to 30 over 8, which you would have to simplify. That would be 15 over 4. Did anybody get that? No. Okay, so that was a little bit more difficult. Okay. Cassandra, this comes all the way back from grade 9. All right, so it's supposed to be. It's supposed to be your knowledge of ratios. Okay, from there. All right. Yes, I certainly can. All right, I can explain it again. That's not a problem. So what we're doing is that we're saying, like, out here at T, our x coordinate is negative 8. Over here, our x coordinate is now negative 2. So because these points lie on the same straight line, there is going to be a proportion. Okay, so the distance from OP to OT, because it's along the same straight line, we can work with a proportion. All right, or with a ratio. Okay, so in other words, what I'm saying is that your x coordinate is to your y coordinate. So you've got your negative 8 at T is to 15 is going to be the same as the negative 2 is to your A. All right. Daniel, if you did that, the problem is that you don't know the length of OP. All right. So you wouldn't, that's not going to help you. All right, to be able to do that. All right, because then you're going to be solving for 2 unknowns. All right. And Paul, what did you do? I had used the gradient of PT. Yeah, you could do that. Yeah, absolutely. Absolutely, and Paul, that's fine. That's not a problem at all. You could do that. Yeah. So what Paul is saying here, the gradient of line OT, so that would be another way to do it. So you could do gradient of line OT. So we know we've got the origin, which was 0 and 0, and we've got negative 8 and 15 are our coordinates. So our change in y, let's say 15 minus 0 over our change in x would be minus 8 minus 0. Oh yeah, so then your starting place is going to be the same as this. Okay, so that's going to be 15 over negative 8. Yeah, nothing wrong with that. Okay, so Cassandra, do you remember direct proportion from grade 9? If things were proportional to one another. Okay, so this is exactly the same thing. All right, so if minus 8 is to 15, then negative 2 is to a. It's a directly proportional relationship. Okay, because they lie along the same straight line. That's why. So in order to be able to solve when things are directly proportional, you were allowed to cross multiply. Right. I'm just trying to think if there's another way in which we could, sorry, please can we mute? Thank you.
Yeah, sorry, I muted him. I think they did it by mistake or something.
Yeah, no, I don't think he did that on purpose. I'm just trying to think if there's another way. Maybe we could look at it like this. If our gradient, because we know that this line goes through the origin, right? So we know that the gradient of our line is 15/8. I think this is what the other person was doing. We'd end up with y equals 15/-8 is our gradient, and then we've got our x. So at this point over here, at point P, we are saying our x coordinate is -2, a is our y coordinate. So if we now go and sub in and we say a equals -15/8, and then over here we put in our -2, can you see you're going to end up with exactly the same answer? You'd end up with that 30/8, which is 15/4. That's maybe another way to think about it if the proportion is maybe a little bit difficult for you to understand. Okay.
They take screenshot.
All right. Are we all right with that, grade 11s? Does that make more sense now? Sorry. Yeah, I was just trying to think about another way I could explain it to you, Cassandra. Okay, so maybe that's better for you. Okay, the line goes through the origin. So we could treat it as it's the line y equals negative something x. Okay. All right, good. I'm glad. Sometimes we just need to explain things in a different way. Okay. All right. What I'm going to do now is I'm going to go and have a look at the grade 12 questions. Grade 11s, you can pay attention to questions 5.1. So 5.1.1, 5.1.2, you can listen to A and B, but this one over here is going to be for the 12s only. Okay, so when I go through question C with the 12s, I'm going to give you grade 11s something else just to work on in the meantime. Okay, and then we're going to carry on going. All right, so grade 11s, this is what you can expect next year. You can see when they've given them a question on Pythagoras in the Cartesian plane, they've tested a little bit of grade 11 work, and then they've gone straight into grade 12 work over here. All right, so grade 12s, hopefully you guys got a chance to do this. Very similar question. You had to calculate the value of K. All right, so that's similar to what you grade 11s did, where you would have to do the theorem of Pythagoras. Okay, you can see they've told them that OP is √5 units long. So the matrix hopefully would have come along and done the theorem of Pythagoras as well. And they would have said that K squared plus 1 squared equals √5 squared. And then they would have worked out that K squared would have been equal to 4. And then same story, P is a point in the second quadrant. Okay, so that means that K would be equal to -2. Okay, so like the grade 11s, yes, Natalie, quite right. 1 mark for subbing into Pythag, another mark on your answer. Hopefully all the matric students were okay with tan theta as well. Also easy, y over x. Okay, so you should have got an answer of -1/2, 1 mark on that matrix. Again, can you see your grade 11 reduction formulae coming through? They've given you the cos of 180 plus theta. So like your grade 11 counterparts, you have to do the reduction first and then go and sub in. Okay, so you should have ended up here with 2/√5. Does that make sense to everybody in matric? Mark there and a mark there. Matrics, are we all good? Yes, sure, okay. All right, now, grade 11s, question C, it does not apply to you. This is a compound angle formulae, so it's just grade 12 work. Whilst I'm doing this question with the grade 11, with the grade 12s, I have got a question here that I want you guys to practice, okay? So I'm just going to put it onto the screen as well. It's this little question down there. I'm just going to copy that and take it across here. Let's get that out the way. Let's get that out the way. All right, and then grade 11s, you can focus. Again, it's just another practice question on, let's just move this over. Go back, and then hopefully this will be big enough for the grade 11s to be able to see. Okay, so grade 11s, you can work on this in the meantime, okay, just while I'm explaining this to the grade 12s. Okay, so grade 11s, you are now doing this. All right, it should be fairly straightforward for everybody, just while I'm explaining to the grade 12s. Okay, so Rosaria, you said, how did I get the -1/2? If you go and have a look up here, we've worked out that k was equal to -2. That's our x coordinate. 1 is our y coordinate. So tan theta is y over x, isn't it? So it's 1 over -2. Okay, does that make sense now? All right, no problem. So matrix, when you saw sine theta plus 60, hopefully all of you said we recognize that. We know that that is our sine compound angle. Okay, and then we would have referred to our formula sheet or from memory, and we would have applied our compound angle expansion. So you would have written this as sine theta cos 60. Remember, sine keeps its sign. And then over here, we would have had cos theta sine 60, like so. There we go. Hopefully now everybody can see all the diagrams. Just trying to fit everything on the screen, which is always a challenge. There we go. Do you not have, mind you, I suppose not all of us would have been able to print it out. Okay. And now subbing in sine theta from this diagram over here, let's just make a summary. Okay, we know that xk in this case was -2. We know that y was equal to 1, and we know that r was equal to √5. Okay, so we're going to have to use some special angles here as well. Sine theta matrix would end up being 1 over, sorry, whoever it is, I'm going to have to move down a little bit. Okay, so the diagram is going to disappear a small amount. There's just unfortunately nothing that I can do about that because I can't write in this tiny space here. So that would have been 1 over √5 multiplied by the cos of 60. We know that the cos of 60 is 1 over 2 plus cos theta. So cos theta, referring to the diagram, is x over r. So that would be -2 over √5 multiplied by the sine of 60, which is √3 over 2. And then here, it's really important that we don't ignore our instructions where it says without using a calculator. All right, so matrix, hopefully we all remember now how to multiply fractions, numerator with numerator, denominator with denominator. So that would give us 1. And then here we would have 2√5. And then here we're adding a negative value. So this is going to become a minus. We've also got 2√5 in the denominator. And at the top here, we've got 2 times root 3. Okay, so that would be our final answer. You could actually leave it just like that. You don't have to write it over the same denominator. They wouldn't mark you down. But if you did want to do that, we would have 2 root 5. And then up at the top here, we would have 1 minus 2 root 3. Okay, so this question, I don't know if you remember, it was out of 5 marks matrix. That's quite a lot. Okay, they're actually trying to be nice. Where would they give us the marks? Well, always for expanding. Then there would be marks for your special angles. Okay, there would also be marks for subbing in from our diagram. Denominators, and then our final answer, like so. Okay, so I don't know if any of the matrix actually managed to get that answer. Are you okay with that question? Any questions? Okay. How are all the other matrix? Are we good? Mercedes, fine. Okay, perfect. Boitchepo, all right. 2. No, Jude, you don't. You don't. And you also don't have to rationalize the denominator. Okay, they won't penalize you for that at all. Okay. Good stuff. Why? No. Square root. Oh, sorry. So this, they wanted us, sorry, matrix. Silly me. Okay, so they wanted us to write it in that form. Okay, all right. So, sorry, I'm half asleep today. Silly me. Okay, they did say in that form. All right. So then what would we do here? What would we need to do in order to get it into root 20? What would be our next step, matrix? Anyone got any ideas? I mean, essentially, what we've done, I mean, it would be root 20 anyway, isn't it? So nothing else is going to change. We would just do that. I mean, there's not going to be a mark on this. The final mark would be over there. Okay, it wouldn't be on what the exactly square root 20 is 2 root 5. Okay, so I suppose just to finish it off, we could do that. There's not really anything else that we can do except just write it down. Okay. All right, there we go. That's done. Okay, so grade 11s, I don't know how you managed to get on with this particular question while we were busy talking. What you would have needed to do here was you would have had to use the theorem of Pythagoras in order to calculate the value of OM, which would have been R in this case. So you should have gone minus 5 squared plus minus 12 squared equals OM squared. You should have worked out that OM squared was 169 and that OM was equal to 13. That's it. Well done. Okay, so in part A, cos theta, what did you guys get as an answer? That's it, Mesh. What did you get for cos theta? You can pop it in the chat. Okay, good. Well done, everybody. Minus 5 over 13 is correct. Beautiful. Good job. Okay. Part B. Yes, that's right, Cassandra. That's right. Avoye. Klumelo. Lovely. Well done. 1 minus sine squared theta. Isimieni, the 13 can't be negative. It's a distance. Okay, it doesn't matter where you write the negative. You can write it at the top or at the bottom. But when you are calculating the length of OM, remember R represents the length of your terminal arm, so it can never be negative. Your coordinates change sign depending which quadrant you're in, but a distance can never be negative. That's right. R is never, ever, ever negative. All right, then 1 minus sine squared theta. You know what I think I would have done here is I would have actually written 1 minus sine squared theta. I would think I would have written that as cos squared theta if it was me. And then because I've got cos theta, and then I would have subbed in like that and got 120. I would have got 25 over 169. That's it. Well done. Good. Well done. And then what did you guys do with question C? What did you do with question C? Sine theta over tan theta. Did you use the tan identity? Nothing wrong with that. I think in this situation, it would have been okay for us to use the tan identity, or if we had said, well, sine theta is y over r. So that gives us negative 12 over 13 in this case. They want us to divide it by tan theta. Tan theta is y over x. So that would be 12 over 5. And then we can do tip and times. So we've got minus 12 over 13 times 5 over 12. Cancel our 12s, and that gives us minus 5 over 13. Did you guys get that answer as well? Oh, you got positive. Did I make a mistake with my signs? Don't think so. Okay. All right. Any questions? And we can jump back to the other work. All good? Okay. All right. So now let's go and have a look at these questions. So grade 12s, you would not have had an opportunity, cool, to look at these questions like the grade 11s did. But you can certainly try them now as we do these. I think that the grade 11s may have begun to struggle. Mind you, I don't know. I don't teach the grade 11s, but certainly question 5.2 down to question 5.4 would be a lot more difficult. Okay, so grade, is that fair? It was hectic. Okay, Cassandra. So after this, it starts to get quite a lot more difficult. Grade 12, we are going to go through your identity and that thing that had the sigma notation on it. And then the grade 11s will be busy with something else as well for a little bit. Okay, but grade 12s, look at these questions too, because they could ask you something like this in your paper. They just didn't in this particular paper, but they could ask you these questions, especially 5.2 and 5.4. Okay. All right, so let's go and have a look at 5.2 first of all. Let's just get rid of this out the way, and we're going to do our solution here underneath. So that was later on for the grade 11s. Let's just move those out the way. Okay, so let's look at 5.2, everybody. 11s and 12s, right? So they give us the sine of 120 times the cos of 210 times the tan of 315 times the cos of 27 all over the sine of 63 times the cos of 540. And look there, guys, again, it says without the use of a calculator. All right, so we cannot ignore that and use a calculator because then they are going to penalize us. All right, the moment we see angles that are bigger than 90, we have to apply reduction formulae. Okay, so either you're going to use 180 minus, 180 plus, 360 minus. You can also, for sine theta and cos theta, you can also use your co-functions, right? Then you've just got to be aware of what happens when you use your co-functions as well. And you'll see there are some co-functions in this particular question, but the angles are already acute. They're not something that we actually need to write in terms of an acute angle. Okay, so sine 120, grade 11s, which quadrant are we in? So if our angle is 120, which quadrant are we in? That's it, we're in the second quadrant. So we're using 180 minus, okay, in the second quadrant. So 180 minus 60 gives us 120. The sine function is positive in the second quadrant. So hopefully we all wrote this as sine 60 when we reduced it. Okay. The next bit, cos 210. Now which quadrant are we in? So if our angle is 210 degrees, exactly, we're in the third quadrant. So we're going to use 180 plus. Okay, so try and use your reduction formula together with a special angle. Okay, because it says without the use of a calculator. All right, so 210 minus 180 is 30. So we know that 30 is one of our special angles. But is cos positive in the third quadrant? No, it's not. So this becomes negative cos 30. Okay, so careful of your signs all the time. Okay. Then tan 315. Which quadrant are we in now? Quadrant 4, absolutely. So in quadrant 4, we have to use 360 minus, but we also need to be aware, all right, that the tan function is negative in the fourth quadrant. Okay, so again, we're going to have a negative ratio. So this is going to reduce to negative tan 45. Okay, like so. Is everybody okay with the first three? Are we all good with the first three? We know why they're negative, and we know why we have the angles that we've got. All right, marvelous. Okay, now, this is something that's very important to the grade 12s as well as the grade 11s, is what I'm highlighting in purple here. This cos 27 and this sine 63. Okay, very, very important to all of us. Okay, irrespective of whether we're in grade 11 or grade 12. When we look at the 27 and the 63, they are already acute. You cannot apply a reduction formula because the angles are already smaller than 90. So something else is going on. All right. When you see the 27 and you see the 63, hopefully you think to yourself, 27 plus 63 is 90. Okay, these angles, 27 and 63, we will add up to 90. So this is a hint that we have to be working with our co-functions. All right, so the cos of 27 is equal to the sine of 63. Okay, the cos of 27 equals the sine of 63. So you have a choice here. Either you can write the cos of 27 as sine 63, or you write sine 63 as cos 27. The choice is yours. Both are perfectly correct. Is everybody okay with why these are equal? Or do you want me to explain that a little bit more? Okay, so Mesh says he's fine. Lesedi says, please explain. Please explain. Okay, so let me do that quickly on the side, right? Those of you that understand this, I'm sorry, just let me do this for the people that are asking me. Okay, not a problem, not a problem, not a problem. Okay, here is a right angled triangle matrix. Okay, there's the right angle over there. This angle over here is 63, and this angle over here is 27. Okay, because the interior angles of a triangle add up to 180 degrees. I'm going to call that side A, I'm going to call that side B, and I'm going to call that side C. Right? Remember, in our basic, in our right angle triangles, we can still work with y over r, x over r, y over x, but we can also work with opposite over adjacent or opposite over hypotenuse, whatever the case is. Okay, so let's start here with this angle. We want the cos of this angle. So the cos of 27 is adjacent over hypotenuse. So this would give us C over A. Right? Now let's look at the sine of 63. Okay, there's 63 over there. Now we're changing our focus. 63 is now our reference angle, our key angle. The sine of any angle is opposite over hypotenuse. So opposite 63 is side C. It's C over A. Okay, so that's why the cos of 27 is equal to the sine of 63. All right, that's where your co-functions come from. And they are so very, very, very important. Okay, in grade 11, you can see this, and in the grade 12, exactly. Absolutely, Sean. That's 100%. 100%. Okay. But that's where it comes from. Okay, it comes from a right angled triangle. All right. So what I'm going to do here, going back to our question, everybody, is I'm going to write the cos of 27 as the sine of 63. You don't have to do that. That's exactly it, Sean. Quite right. And you would have learned that in grade 11. You're in grade 12 now, aren't you, Sean? Okay, and then here we've got the sine of 63 at the bottom, and then the cos of 540. Okay, so when angles are bigger than 360, we have to take away 360, and then we end up in the same quadrant. Okay, so this would be the cos of 180. Okay, so this is what we would have to write in our first line. We have to show that we've applied our reduction formulae. Here where we've got a co-function, that we've written them as the same, and there where we had an angle that was bigger than 360, that we have subtracted a multiple of 360. Okay, so now what I can do, or what I would do, is I would say anything divided by itself is 1, and I would get rid of those guys. All right. What you're supposed to do as far as the denominator is concerned is you're supposed to think about your graph, right? So your cos graph, if you remember, looks like that. Okay, so your maximum is at 1, your minimum is at -1. This is 90. So there's your minimum at 180 degrees. Okay, so the cos of 180 is -1. What we can do now is we can start subbing in our special angles. So this is where our triangles could be really important to us. Let's go and fetch them. Why not? Where were they? There they are. So I'll get this triangle, that triangle. Okay, so these we need to learn off by heart, remember, because they're not given to us. But I'm just going to steal them and stick them over there. Okay, so now First triangle is for 45. The second triangle is for 60. Okay, so the sine of 60. Okay, there we are. There's 60. So that would be opposite over hypotenuse. That's why it is root 3 over 2 multiplied by negative cos 30. There's 30. So that would be adjacent over hypotenuse. All right, so that would be root 3 over 2 as well. Again, can you see the 30 and the 60 add up to 90? So the cos of 30 and the sine of 60 are the same, in the same way that the cos of 27 equals the sine of 63, multiplied by the tan of 45. Okay, so if we over here, 45, y over x. So you could write that as 1 over root 2. Or it's also accepted to write it as root 2 over 2 where it's been rationalized. It's the same thing, doesn't matter. And then at the bottom, we are dividing by negative 1, which is the cos of 180. Yes, did I not say that it was negative? Michaela? Yes, so the tan of 45 is 1. Sorry, but it's supposed to be, oh, sorry, I've left off the negative here. It's supposed to be negative because we've got our negative over there. Okay. Yeah, tan 45 is negative 1. Okay, so in this particular case, because remember it came from the tan of 315, so it's negative 1. Will we need special angles in grade 12? Yes, yes, yes. Very important. Very, very important in grade 12. Okay, so if you haven't learned these triangles or the fan off by heart, make sure that you know them, Cassandra. Okay, special angles are even more important in grade 12 than they are in grade 11. Okay, so Lesedi, it depends how you've learned it. Okay, so am I being a muppet here? Oh, sorry, guys. Sorry. The tan of 40, it's negative 1. Sorry. I'm thinking about the sine and the cos of 45 degrees. Sorry. So the tan of 45 is 1. It's negative because it came from the negative over there. All right. My apologies. Sorry. And then the cos of 180 would be equal to negative 1 as well. Okay. So finally, those would cancel. Their signs would cancel as well and give us a positive, and we would end up with a negative answer. Root 3 times root 3 would be 3, and 2 times 2 would be 4. And there we go. We would be done with it. Okay. Sorry, I was thinking about the sine and the cos of 45, not tan of 45. My apologies. No wonder you were a little bit confused. Sorry, guys. Okay, so we can see that's out of 7 marks. So what would they give us marks for? Well, they would give us marks for our reducing. They would definitely give us a mark for writing cos 27 as sine 63, or in the denominator sine 63 as cos 27. And 1, 2, 3, 4. There would definitely be a mark for subbing in our special angles. There'd be a mark on our answer. What are we up to? 1, 2, 3, 4, 5, 6. And then here, I think there would be a mark on the cos 180 as well. Okay. So Cassandra, I know you said that this was hectic and terrible. Is that a little bit better now? All right, Shantae, not a problem. Oh, good. Oh, I'm so glad. Okay, so Shantae, just going back here, remember we had to reduce the tan of 315. So that was 4th quadrant where tan is negative. Okay, so we would have used tan 360 minus 45, and that's why it reduces to negative tan 45, which is what we had over here. Okay, so the tan of 45 is equal to 1, so it would have been negative 1. Okay, Shantae, again, your graph. Okay, cos 180, that's what this was over here, your cos graph. Okay, so at 180 degrees, that's when you've got your minimum of on your cos graph of -1. Okay, so these these are things we have to learn. We have to learn our reduction formulae. We need to know our basic graphs, because that also helps us with all of this. Okay, pleasure, no problem. All right, I tell you what, let's jump forward and go and have a look at the identity. So the identities here, the idea is the same, except obviously the grade 12 stuff involves grade 12 things, which I will go and explain to you now. But I selected identities where in both cases we were subtracting fractions. Okay, so for grade 11s and for grade 12s, when we are working with identities and they want us to work with fractions, we've got to remember all the rules regarding fractions from grade 8, grade 9, etc., etc. Right, so what I'm going to do is, instead of writing everywhere, I'm just going to delete what I've got here now. Hopefully we took screenshots if we needed to. And I'm going to utilize the same space so that we don't have writing all over. Okay. All right. So I'm going to do the grade 11 identity, and then I'm going to do the grade 12 identity. Grade 11s, when I do the grade 12 identity, I'm going to give you another identity to work on. Okay, so grade 11 identity first. Grade 12s, again, you need to know this anyway. You've just got additional work that we would need to consider. All right, so we've got to split up the left and the right. On the left-hand side, we have 1 over cos theta minus cos theta over 1 plus sine theta. When you add fractions with different denominators, you've got to have an LCD. So your lowest common denominator is going to come from multiplying your denominators together. So your denominator is going to be cos theta multiplied by 1 plus sine theta. That's your LCD. So essentially what you are doing is that you are multiplying this by 1 plus sine theta, so you're timesing that by 1 plus sine theta. You're timesing this by cos theta, so you're timesing this by cos theta. So it's exactly the same as if you were doing something like 1 over 3 plus 2 over 5. Your denominator comes from multiplying the denominators together. 3 times 5 is 15. So you'd have to times that by 5 and that by 5 and that by 3 and that by 3. It's exactly the same idea. So at the top, we've got 1 times 1 plus sine theta. And over here, we've got cos theta times cos theta, which is cos squared theta. So now we've got 1 plus sine theta minus cos squared theta all over cos theta times 1 plus sine theta. Okay, so now we have to start getting a little bit creative. We have to think about the identities that we have learned and that we could potentially use in a situation like this. Okay, so grade 11s or grade 12s, what do you suggest we do next? So we found an LCD, We can't cancel over pluses and minuses. What could we do next? Lesedi? You're welcome to unmute and speak, Lesedi.
Hi, ma'am.
Hello. What would you do here?
Hi, ma'am. Can you?
I can hear you breaking up just a little bit, Lesedi.
Okay, can you hear me now?
I can hear you now.
Okay, ma'am. I think we should change the negative cos squared theta into sine squared theta minus 1.
Okay, you mean the other way around, 1 minus sine squared theta. Yes,
Yes.
absolutely. Absolutely. That you can do that. That's one option. Absolutely. All right. You could also work with the 1, but I'm going to do what you said. Okay, so Lesedi says, all right, change this cos squared theta to 1 minus sine squared theta. Nothing wrong with that. So cos theta, and here we've got 1 plus sine theta. So now we need to get rid of our brackets. Okay, so this would give us 1 plus sine theta minus 1 plus sine squared theta all over cos theta times 1 plus sine theta. So now in your numerator, let's just move all our stuff out the way here. Let's just move this down. In our numerator here, we've got sine squared theta plus sine theta over cos theta times 1 plus sine theta. Okay, so after we have applied an identity, so in this case, writing cos squared theta is 1 minus sine squared theta, now we have to factorize. Okay, so at the top, we would take out sine theta as our highest common factor. This would leave us with sine theta plus 1 over cos theta, and then here we've got 1 plus sine theta. So inside our brackets, grade 11s and grade 12s, sine theta plus 1 or 1 plus sine theta, it is the same thing. Okay, both sine theta and 1 are positive. So now we would cancel something at the top with something at the bottom. We could only cancel after we have factorized because we're allowed to cancel factors, not terms. This gives us sine theta over cos theta, which we know is tan theta. And now the left-hand side is equal to the right-hand side. Okay, oh wow, out of 5 marks. That's an awful lot, isn't it? Okay, so Oratile, yes, go for it. Oratile, you want to ask something? Anybody else want to ask anything? Does this make sense to you? Grade 11s, are you okay? Are you sure? Okay, Oratile, go for it. Unmute on your side.
Hello, madam.
Hello.
So, madam, would it be wrong if I said 1 plus sine theta is equals to cos theta?
That's incorrect.
That's incorrect. Okay.
That's incorrect. Yes. Yes, that's not true.
Thank you, madam.
Okay. All right. No problem. Okay. So unfortunately, that's not true. So we've got to use our identities. We can't make up stuff that isn't true. Okay. All right, so for Zama, you can't pull cos out as a highest common factor here because it isn't a highest common factor. Okay, so in other words, when you want to factorize, you have to have or take something out as a highest common factor. You can't take cos squared theta from sine theta. Okay, you can't do that. So your only alternative here would have been to rewrite that one. So in other words, to take this one over here, you could have written that as sine squared theta plus cos squared theta plus sine theta and then minus cos squared theta. You could do that. And then at the bottom, you've got your cos theta 1 plus sine theta. But even then, you're not going to be able to take out, and then those will add up to 0. That would have been your only alternative at this point. But you can't, it's like if I've got 2x plus 7, can I take out 7 as a, well, I suppose you could in that situation, but you can't take out something that you don't have when you're factorizing. Okay, Hlumelo?
Ma'am, why didn't we just cancel out 1 plus sine theta at the top and the bottom on the second step?
Okay, but you're not allowed to cancel over plus and minus signs. Okay, so you've got a minus sign here. So you're not allowed to do that. You can't cancel over plus and minus. So if you look here, is it Hlumelo? Am I pronouncing your name correctly? Yes. Okay. So Hlumelo, look at this. Okay. If I say 2 plus 3, and then at the bottom I say 2 plus 5, can I come along and do that and say my answer is 3 over 5? Is that allowed? It's not allowed. Okay, because it's not true. Okay. All right. No, you can't do that. Because look, if I answer this question in a different way, so if I say 2 plus 3 is 5 and 2 plus 5 is 7, are 5 over 7 and 3 over 5, are they equivalent fractions? No. Okay, so you cannot cancel over plus and minus signs. That's why we have to factorize. Okay, so you'll see the more you practice these, Hlumelo, the easier it'll become. You find your lowest common denominator. All right, after that, you have to apply an identity. All right, after you've applied an identity, you are going to factorize. And after factorizing, maybe collect like terms, apply another identity, whatever the case is. Okay, but you cannot cancel over plus or minus signs. All right. Okay, so now I need to do the matric identity with the matrix. So the grade 11s are going to do this identity over here. All right, so let me just make this a little bit bigger for the grade 12s because it is a bit small. Okay, so grade 12s, we're looking at 5.2. Grade 11s, I'm going to give you this identity over here to work on. And if you're finished, you can always try and simplify this as well. All right, I don't know how long I'm going to be with the grade 12s here, but this is now so this is, you're going to prove, this is your identity in A, and in B, you're going to simplify. Okay, so the grade 11s are busy with this while I'm doing the grade 12 identity 5.2 over here. And then I think what I'll do, grade 12s, is just do the second question with you because that's a little bit of problem solving. Oh, hang on a second. Let's just move that over. Can everybody see everything? I think so. Okay, going forward with our other lessons, there's not going to be a difference with the grade 11 and the grade 12. Okay, we're going to focus more on the grade 11 stuff that you are not taught, but I wanted to have an opportunity to at least to trig with you because There is so much. And also because I wanted you guys to see, especially the grade 11s, I wanted you to see how everything that you've learned in grade 12, in grade 11 is important for grade 12 as well. Okay. All right. So grade 12s, let's have a look at 5.2. Grade 11s, you're going to prove the prove the identity, and then go and have a look at the simplification. Okay, just give me 1 second to answer a direct message. Okay. All right, so did you find this difficult, grade 12s? Did anybody try question 5.2? Did you find this difficult? Did you find it difficult, Lasedi? Okay. Yes, okay. No, this is difficult. Okay. All right. So like we were saying to the grade 11 counterparts, you tried and got stuck, Gugu, sure. Like we were saying, this is why the listening to the grade 11 stuff is so important for you guys, because I'm going to be saying pretty much the same thing. You've just got these additional identities and compound angle formulae that you need to know. You are subtracting fractions that have got different denominators. So like what we were just doing with the grade 11s over here, you've got to find a lowest common denominator by multiplying those denominators together. All right, so let's just get this down. And then what I'm going to do, that's going to be my first step, is I'm subtracting fractions. I've got to have the same denominator. So the denominator is going to be cos x minus sine x, and use brackets, guys. Don't use dots. Okay, like a lot of the time, I know dots means times, but a lot of the time you'll see students will write a binomial times a binomial and they'll just put a dot in between. I promise you, you're going to get confused. Use brackets. Okay, it's much better. And then here we've got cos x plus sine x, like so. So just like we were doing with the others, I'm timesing this over here, the cos x minus sine x, I'm timesing it by cos x plus sine x. So I've got to do the same thing to the numerator. Okay, so I'm going to take cos x plus sine x, which is my numerator, and I'm multiplying it by itself, which is cos x plus sine x. Then I've got my minus. Okay, on the right-hand side of my fraction, I had cos x plus sine x in the denominator, so I have to multiply my numerator, cos x minus sine x, by cos x plus sine x. Is everybody happy with that? Grade 12s, does that make sense to you? Before I go on. No, okay. Remember earlier we said, if you have 1 over 3 minus 2 over 5, you have to multiply 3 and 5 together to get the denominator. And then at the top over here, what you times the denominator by, you're timesing the numerator by. Okay, what you're multiplying the denominator by, you're multiplying the numerator by. Do you remember that? Okay, that's exactly what I'm doing. Okay, so your denominator is cos x minus sine x times cos x plus sine x. Okay, like the 3 times 5. Now I've got to take the cos x plus sin x at the top. And I have to multiply it, what I was multiplying its denominator by. Okay, oh, you get it now, Sean. Okay, so that was multiplying it by cos x plus sin x. Okay. Then at the bottom over here, I had cos x plus sin x. So I multiplied that by cos x minus sin x to get the denominator. So I've got to do the same thing at the top. Okay, what I multiplied the bottom by, I've got to multiply the top by the same thing. Okay, so where I said 3 times 5 at the bottom, I had to say 1 times 5 at the top. Where I said 5 times 3 at the bottom, I've got to say 2 times 3 at the top. Okay, so here I've got cos x minus sin x, and I have to multiply that by cos x minus sin x. Does that make more sense? Yes. Okay, so what I multiplied the bottom by, I'm multiplying the top by the same thing. Okay, makes sense now. Okay, so you've got to think about it as a simple fraction like this, grade 12s, and then it's easy. Okay, so now let's multiply out our brackets. We're going to FOIL. Okay, so that gives us cos squared x. In fact, the grade 11s could listen to this as well, because there's not really anything that we're doing here that they wouldn't they wouldn't know. Okay, then in the middle, we would get sin x cos x, sin x cos x. So that would give us 2 sin x cos x plus sin squared x. Okay, minus, and then I've got to keep my brackets. Here I'm going to end up with cos squared x minus 2 sin x cos x plus sin squared x. And all of this is still over my denominator, cos x minus sin x, cos x plus sin x. Okay. All right, let's get, is everybody, are all the matrix okay so far as well? I've just foiled my brackets. Does that make sense to everybody? Yes, are we all good? Okay. So now I'm going to remove the brackets, right? So we've got cos squared x plus 2 sin x cos x plus sin squared x minus cos squared x plus 2 sin x cos x minus sin squared x. Okay, so all the terms inside the brackets changed sign. Okay, and this is over cos x minus sin x times cos x plus sin x. All right, so let's collect some like terms here. What do we have? So cos squared x minus cos squared x is 0. And sin squared x minus sin squared x is also 0. So I have got 2 sin x cos x plus 2 sin x cos x. So I'm going to write that as 2 of 2 sin x cos x. Instead of writing it as 4 sin x cos x so that I can apply my double angle identity. Okay. At the bottom, all right, I'm going to FOIL. and I'm going to multiply my brackets out. Is everybody happy that if I did that, I end up with cos squared x minus sine squared x? Does that make sense? Everybody happy so far? Okay. All right, so now this is the part where if any grade 11s were listening to us, Lichlu, where are you lost? Okay, so the denominator, I'm just foiling the denominator. It's difference of two squares. I'm foiling the denominator and it's difference of two squares. Does that make sense? It's iPhone. Does that make sense to you? I'm foiling the denominator, multiplying the brackets out. Okay, it's difference of two squares. Okay, so that's why it becomes cos squared x minus sine squared x. Okay, and then grade 12s, what we're doing now is we're looking at, where are they? Okay, we're looking at this, isn't it? Okay, here's our formulae, our grade 12 trig formula. And that's why we're saying at this point over here now, we've left our grade 11s behind, okay, because they don't know these formulae like you do. Okay, so here, all of us can see this is this, isn't it? Over there. So in the numerator matrix, we've got 2 of sine 2x. In the denominator, we've got our cosine, or at least one of our cosine double angles. So cos squared a minus sine squared a. Look at our denominator. It's the same. Okay, so our denominator looks like this. And we see it over there. Okay, and this is where we now do the reversal of the expansion, and we end up with cos 2x. Okay, and that's how come we end up with 2 tan 2x, which is what we had on our right-hand side. Okay. Are you all right, matrix? Okay. Good stuff. You sure? Any questions? Because we're going to go back to the grade 11s now, and we're going to go and have a look at that general solution. Okay, which would apply to you matrix as well. Okay. All right. Okay. Grade 11s, are you hanging in there? Were you able to prove that identity? Could you prove that? Oh, wow, Gugu. That's interesting.
Yeah, I wasn't expecting
We would have
that
to,
one.
we would have to report that.
Yeah.
Okay. So grade 11s, I'm speaking specifically to you now. Did you try the questions, the things in orange? Were you okay? Were you able to prove the left-hand side equal the right-hand side? Oratila, you got stuck. Katlejo, you were fine. Okay, it didn't work. Okay, so just very quickly, because we're going to go over and do the identity now. I mean, not the identity, the general solution. Let's just have a look at proving left-hand side equals right-hand side. Okay, so when we see a square on anything, it means that we have to multiply something by itself. So you would have said sine theta plus cos theta times sine theta plus cos theta. And then you would have done FOIL. So you would have said sine theta times sine theta is sine squared theta. Sine theta times cos theta is sine theta cos theta. And then with your inners, you would have also done the same thing. Sine theta times cos theta is sine theta cos theta. And last times last, cos theta times cos theta is cos squared theta. So in algebra, if you have xy and you add xy, that gives you 2xy, doesn't it? So that's what's happening here. If you've got sine theta cos theta and you add sine theta cos theta, you've got 2 sine theta cos theta. Right. The other thing that's going on here is you've got your square identity. Right, so sine squared theta plus cos squared theta is equal to 1. Okay, so if we put sine squared theta and cos squared theta next to each other, and our 2 sine theta cos theta at the end, we could say these add up to 1. And that's how we have 1 plus 2 sine theta cos theta. Okay, all right, there we go. Okay, so that's what you would have done. That one's a little bit easier than the exam one. That's why I wanted to give you something that wasn't too difficult so that you didn't feel sort of discouraged while I was working with the grade 12s. Okay, all of these results here are important, irrespective of whether we are in grade 11 or whether we are in grade 12. Okay, so let's go back and let's go and have a look at the general solution. Okay, so this sort of general solution, grade 11 and grade 12s, it's important for us. Let's just give ourselves a little bit of room here. Oopsie daisy, sorry. What happened there? Let's just. Okay. So grade 11s, I mean, grade 12s, you wouldn't have seen this one, but that's fine. Grade 11s were given this to work through. So this is beneficial for all of us. So general solutions. Okay, so they give us 3 sine x equals 2 tan x. Okay. What do you think the first step is? Grade 11 or grade 12? What do you think the first step is in this case? Okay, so Lebogang says make sine x the subject. Anyone got any other suggestions or would do something a little bit differently? Kutwano, Mesh, Orotile. Exactly. So we've got to apply our tan identity. Good thinking. Okay, so we're going to apply our tan identity. So we're going to leave 3 sine x as it is. And over here, we're going to write this as 2, and we're going to write sine x over cos x. Good, well done. That should get us 1 mark out of 6. What do you think we do next? Lebogang, it's not wrong, but it doesn't help you find a solution. Okay, so if you did do that, you would still need to change tan x to sine x over cos x. Okay, so no, it's not wrong. That's okay, as long as you wrote tan x to sine x over cos x as your next step. Okay, don't we get x on its own, but we're doing a general solution. We're doing a general solution, iPhone. Okay, so we're not solving for x. We're not solving the equation. We're getting the general solution. So we're not getting x on its own. Okay, there we go. Mbali and Zanele. Lovely. Okay, cross multiply. Okay, so Lebachang, you would have done the same thing. If you'd isolated sine x, now you've got 2 over 3 tan x, then write tan x as sine x over cos x, and do what Mbali and Zanele say, cross multiply. Okay, so this is going to give us 3 sine x cos x equals 2 sine x, like so. Good. Okay, so cross multiplying gets rid of the denominator. Okay, sorry, I was just adjusting my seat. Okay, now what do you think we do? Matrix in grade 11s, what do you think we do next? Any suggestions? Okay, but Michaela, if you divide by 2x on both sides, then you're going to get rid of your x's. You can't have the words sine and cos without an angle. Okay, okay, Mbali and Zanele, are you allowed to divide by sine x? Is that a thing? Are we allowed to do that? Are we allowed to divide by sine x? Is that a rule? Okay, so unfortunately, we're not allowed to divide sine x or divide by sine x. Ah, Fazama, nice. Okay. All right, look at what Fazama has said. Fazama has said move 2 sine x to the left hand side, and then we're going to make it equal to 0, Mesh. Okay, good, well done. You are not allowed to divide by sine x. You can take sine x and you can divide it by cos x, because that is an identity. It gives us tan x, but that's the only thing that you're allowed to do. Okay, so you can divide sine x by cos x to get tan x, but you cannot divide by sine x. All right, so it's like this. If you have got an equation, let's say I'm asking you to solve for x, and I give you x squared minus 2x equals 0. Can I divide by x here and divide by x here? Is that allowed? Am I allowed to divide by x? Is that allowed in an equation? No. Okay, so it's not allowed. It's not allowed for 2 reasons. Number one, what if x was 0? Okay, so division by 0 cannot take place. Also, if I do that, I'm losing one of my solutions. Okay, so I'm not allowed to do that. So you are not allowed to divide by sine x. You can only divide sine x by cos x, because that is an identity. Okay, but you can't go around dividing by sine x or by tan x. All right, so this is the only time that dividing by cos x is allowed. Okay. We're going to do what Fazama said. We're going to take we're going to leave 3 sine x cos x on the left, and we're going to take the 2 sine x over to the left-hand side. And we're going to do what Mesh said, and we're going to make it equal to 0. And now that we have done this, we can factorize. Okay, so we're going to take out sine x as our highest common factor, grade 11s and grade 12s. And in brackets, we are left with 3 cos x minus 2 equals 0. Okay, so we've taken out a highest common factor. Let's just get rid of all of this stuff. Does that make sense to everybody? Okay, so what we actually had to do was move them onto the same side so that we could factorize. Okay, so remember, we've always got to think about factorizing. Pretty much everything that we do involves factorizing of some description. Absolutely, Oratile. Yes, yes, yes. And now we're going to write down either sine x equals 0 or cos x equals 2/3. Good. And now we have to do our general solutions. Okay, so remember our general solutions have that plus k times 360 or plus k times 180 in them. All right, so before we do that, we find a PAA or a reference angle or a key angle. I don't know what your teachers call it at school. A lot of them call them reference angles. Okay, I call it a PAA. It's also sometimes called a key angle. Okay, and here it would be 0 degrees. And again, you're thinking about your sine graph. Okay, so your sine graph at 0 degrees, it's equal to 0. Okay, we treat this 0 as though it is positive. Okay, it's the only place that we do that. And we think about the cast diagram. Right, so our ratio is positive because it's 0. So that means the sine function is positive in quadrants 1 and 2. So we've got to do solutions in quadrant 1 and quadrant 2. In quadrant 1, we write x, our angle, is equal to our reference angle, or PAA, which is 0 degrees, plus k times 360. K is an element of the integers. In quadrant 2, we have x equals 180 minus our PAA or RA or key angle plus k times 360. K is an element of the integers. So that means that x would be equal to 180 plus k times 360. K is an element of the integers. All right, on the other side, are we all okay? Is that making sense to everybody? Any questions? All right, Fazama, what did you not understand? Can you just be specific with me and just tell me what you didn't understand? Yeah. Okay. Maybe, Fazama, maybe you can speak to Yolanda. Yolanda, maybe you can just DM Fazama and just see what you didn't understand.
Okay.
Please. Okay. Thank you so much. All right. Everybody else. Again, we're going to find our reference angle, key angle, RA, whatever the case is. Okay, so shift cos, and we're going to put in 2/3. You should see you'll be getting a reference angle of 48,19 degrees. Okay, again, this ratio is positive. It's positive 2/3. So now we've got to do solutions or general solutions in the quadrants in which cos x is positive. That is quadrant 1 and quadrant 4. So here we would say x equals, in quadrant 1, our PAA plus k times 360. And in quadrant 4, we would have 360 minus which would give us a final answer of 311,81. That's it. Okay, so I see there's some hands ups. Not a problem. iPhone. Sorry, I'm calling you iPhone, but I don't know what your name is. You're welcome to unmute and speak.
Hello, ma'am.
Hello. What's your
Ma'am,
question?
the reference angle that we got from the cos x that equals positive 2/3, is that because we say shift cos 2/3 on the
Correct.
calculators?
Correct. That's what you say on the calculator. So
Okay.
you've got to tell the calculator to work out the angle. So you tell it to work out the angle by saying shift cos.
Okay, thank you, ma'am.
Perfect. No problem. Let's see who else had a hand up. Oh, I think there was another hand up. Okay. Any other questions on this general solution? Are we sure that we're okay? Gugu, yes, go for it, Gugu. You're welcome to unmute, Gugu. Rosaria, as far as I know, these will be recorded and they will be available exclusively to you guys. Okay, yes, that's. Gugu, put unmute. Oh, there. Sorry.
I don't know what was wrong with my speaker. Can you hear me now?
I can hear you, Gugu. Go for it.
So, ma'am, my question is not related to this specific question, but it is on general solution. So if we have tan theta, maybe like tan 5 theta equals to tan theta, then what do we do?
Okay, so that would be considered extension for grade 11s, although their teachers may have been shown this. If you end up with something like that, all right, what you would do is that you would treat this like this is your angle, and you would treat that like it was your reference angle almost. Again, what you would say here is that what's on the left is equal to something on the right that's positive. So you would do a solution in quadrant 1 and quadrant 3. All right, so your angle theta would be equal to, so now we're talking about quadrant number 1. Okay, so theta would be equal to your PAA, so 5 theta plus k times 180. K is an element of the integers. All right, and in this case, because it's tan and tan and you've used 180, you don't have to do a solution in quadrant number 3. All right, so this would give us negative 4 theta and then you would divide through by negative 4. This would be the quickest way to do the answer to this one. Okay, so then you'd end up with theta equals, it doesn't matter whether this is plus or minus, and then 180, that would be 45, wouldn't it? So it would be k times, and that's all you'd have. Okay.
Oh, okay, ma'am. Thank you.
All right, no problem. Okay. Any other questions about anything that we have covered today?
And we have the poll. Don't forget. Please don't jump
Do we
off.
have a do we have a poll?
Yes, we can.
Oh, I didn't
poll
realize
just
that we were running a poll today. Okay.
it's just so that we can take a register. I mean, you can continue. We still have 5 minutes left. But
Okay. All right. Well, what I would like to do is I would just like to do for the matrics, I would just like to do this question over here, question 5.3. The grade 11s can listen. Okay, but because it actually involves something that you learn in grade 11. Michaela, you can do it 2 ways. All right. When you've got a general solution for tan, if you want to work in quadrant 1 and quadrant 3 and do k times 360, that's fine. But then you have to have both general solutions. Or you can just work in one quadrant and do k times 180. Okay, Michaela? And that's because your tan function repeats itself every 180 degrees. That's why we're allowed to do that. Okay. So you can do a 360 if you want to. Okay, it's not a problem at all. And in fact, you'll see, oh no, it's, I don't think it's in this one. Yeah, we're not going to do trig again. Sorry, I was just thinking I could show you, but I think you're in grade 11, aren't you, Michaela? You're not one of my students in grade 12. All right, so grade 11s, you can listen to this because you can see what comes through from grade 11. I appreciate that you've not done sigma notation and that would seem a little bit intimidating to you. But you're very welcome just to listen to this. I just want to do this with the grade 12s before we say goodbye. Okay, so evaluate without using the calculator. Right, so here we've got the sum of from A equals 38 to 52 of cos squared A. Okay, so matrix, we know from sigma notation that the number at the bottom is where we start subbing in. The number at the top is where we end subbing in. So subbing into our series, we'd end up with cos squared 38 plus cos squared 39 plus cos squared 40. And so we would go on until eventually we got to cos squared 51, cos squared 52, like so, right? So after we finished subbing in, now we're looking at it. And this is where this is grade 11 work. Okay, what we've just done is grade 12, but our next steps are grade 11 steps. Okay, we're looking at cos squared 38 and cos squared 52. And what do we see about the 38 and the 52? What's 38 plus 52? It's 90, exactly. So this means that we've got to use co-functions. All right, now the other thing that is exactly, they're complementary angles. The other thing that we know is that sine squared theta plus cos squared theta is 1. Okay, so if you have got sine squared 52 and you add cos squared 52, you'd end up with 1. If you had sine squared 51 plus cos squared 51, you'd end up with 1 as well. So this question is on co-functions. It uses co-functions and it uses our square identity. We are going to rewrite cos squared 38 as sine squared 52. Isn't that sneaky? And we are going to write cos squared 39 as sine squared 51. All right, and we're going to write cos squared 40 as sine squared 50 plus. Duck, 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 duck. And then we get down here to the end, and we've got cos squared 51 plus cos squared 52, right? Now, in the middle of all of this, we've got cos squared 45. And cos squared 45 and sine squared 45 are equal to each other. All right, that's right in the middle, okay? So this one over here, let's choose a different color. Oh, that orange is so ugly. This one over here and this one over here add up to 1. and this one over here, and this one over here, add up to 1. So how many times, Matrix, are we adding 1 to itself here? How many times are we adding the 1 to itself? We've got the 52, we've got the 51, we've got the 50, 49, 48, 47, 46. Because remember, when we get to cos squared 45 and sine squared 45 is the same thing. That's going to be in the middle. So does that make sense to you that we would have 7 groups of 1, and then we've still got our cos squared 45 that's in the middle? Right. Tell you what, Gugu. Not that they expect us to do this. Okay, no problem. So we've got the 52, the 51, the 50, 49, 48, 47, 46. Okay, so sine squared 52 plus cos squared 52. Sine squared 51 plus cos squared 51. Sine squared 50 plus cos squared 50. Okay, so there are 7 groups of 1 that we are adding together, plus our cos squared 45, which is in the middle. Okay, all right. So that's going to be 7 plus. We know that the cos of 45 is root 2 over 2. And we have to square that, don't we? Okay, so this gives us 7 plus. That would be 2 over 4. So our final answer would be 7.5. Okay, so a little bit of problem solving. Okay, so how do you like that? They've brought through sigma notation from paper 1, and then they've combined it with co-functions and the square identity. Okay, all right, please do the poll. And then next week, we are going to be doing exactly the same work in grade 11 that we are doing in grade 12. Okay. On analytical.
Nice, guys. You guys did a good job by going through the question paper before. I think that makes life a little
It
bit
does help.
easy.
Yeah, no,
Yeah.
it does help. Oh, it's a pleasure. No, this would be a level 4 question, Lebogang. Actually, is it a level 3? Yeah, I think you're right. I think you're right. I think it is a level 3 question. I don't think it is a level 4 question, Lebogang. Yeah. Pleasure.